Welcome to the Deep Dive. I'm your host, and today, we're embarking on a pretty crucial mission, diving deep into the expansive world of AWS. This deep dive is specifically tailored for anyone out there preparing for the CLG-C02 AWS Certified Cloud Practitioner exam. Our goal, like always, is to cut through all the noise, extract those essential nuggets of knowledge, and really offer you a clear shortcut to being truly well informed. And that's not just for the exam, but for understanding the fundamental why behind cloud computing itself. Okay, so let's try and unpack this a bit. The AWS Certified Cloud Practitioner exam, it covers such a vast landscape of services and concepts, it can feel overwhelming. It's definitely not just about memorizing names. It's about grasping their purpose, their benefits, and, maybe most critically, how they all fit together into a larger, coherent cloud strategy. So today, our journey is all about navigating that landscape efficiently. We want to understand not just what these services are, but why they matter to you, the user, as you prepare for certification, and maybe even more importantly, for using this stuff in the real world.
Yeah, that's a broke way to frame it. What's truly fascinating here, I think, is that while the immediate goal for many people listening is probably certification, the underlying aim, the real value, is true comprehension. It's about building a really robust mental model of how AWS fundamentally works. So we'll be connecting the dots between those foundational services, digging into the critical aspects of cost management, which is always huge, understanding the pillars of cloud security, and exploring the operational best practices that are just absolutely crucial in any successful cloud environment. Like you said, this isn't just about passing a test. It's really about equipping you with a foundational understanding that, empowers you.
Exactly. So for the next little while, expect a comprehensive yet hopefully engaging journey. We'll be traversing through the core AWS services, looking at how they fit together like pieces of a puzzle, right? And how they can be managed effectively to keep those costs in check, and ultimately how they all contribute to a well-architected cloud solution. One that's secure, resilient, and performant. Think of us as your guides through the AWS ecosystem, really trying to highlight what you truly need to know and understand rather than just, memorize a list of facts. All right, let's kick off with the absolute core stuff. When we talk about building pretty much anything in the cloud, whether it's a simple blog or some complex enterprise application dot dot dot, we almost always start with where our applications actually run and where our data lives. These are the fundamental components, the real staples of cloud computing.
Precisely. And the broader implication here, connecting it back to the exam and just general understanding, is that understanding these foundational services is, it's non-negotiable for anyone stepping into the cloud. They really are the building blocks. Almost everything else in AWS is constructed on top of these. Without a solid grasp of these, the more advanced concepts, they become much, much harder to contextualize or apply effectively later on.
So let's start with the workhorse of compute then. Amazon EC2. What exactly is an EC2 instance? And from a practical standpoint, why is it so fundamental to AWS?
Okay, yeah. Amazon EC2 instances are essentially your virtual servers in the cloud. Think of them like individual computers that you can rent, by the hour or even by the second, existing entirely within AWS's data centers. They provide scalable computing capacity. And that scalability is key. It means you can easily increase or decrease your processing power as needed. But the true insight of EC2, I think, isn't just scalable servers. It's that profound shift from capital expenditure buying hardware up front to operational expenditure. You're no longer guessing how many servers you'll need for the next 3 years and making that big purchase. Nope. You're paying for compute capacity literally by the second. In some cases, aligning your costs directly with demand. This radically de-risks new ventures, and allows for incredible agility in development and deployment. You've got the flexibility to launch as many or as few virtual servers as your workload requires, and you retain complete control over their operating system, security settings, networking configurations, making it a prime example of what we call infrastructure as a service, or IaaS.
That flexibility sounds incredibly powerful. But speaking of costs, which always comes up, what are some of the less obvious billing nuances people often miss with EC2, particularly that per second billing thing?
Yeah, that's a crucial detail for optimizing costs. Definitely something the exam might touch on implicitly. Per second billing is available, but only for instances launched in specific popular operating systems. Think Amazon Linux, Windows, Red Hat Enterprise Linux, Ubuntu. This is a real game changer because you literally pay only for the seconds you use your instance. It takes the cost of unused minutes or partial hours right off your bill. So imagine running a batch job that finishes in, say, 45 minutes. With per second billing, you only pay for those 45 minutes, not the full hour.
Oh, okay.
However, and this is the important bit for other maybe less common operating systems, like CentOS, for instance, each partial instance hour consumed is still billed as a full hour. So that distinction can significantly impact your costs over time. Understanding your OS choice is actually vital for cost efficiency. And remember, as an IaaS offering, EC2 provides the basic computing building blocks. But it's your responsibility as the customer to manage the guest operating system, your applications, and your security group configurations. AWS handles the hardware, you handle the OS and up.
Now, when we have these EC2 instances running, especially if they're hosting, performance-sensitive things like databases, what's the go-to storage option? The one that gives you high performance and durability, and why is it the recommended one?
Right. So for frequently changing databases running on an EC2 instance, or really any data that needs frequent granular updates and low latency access, Amazon EBS Elastic Block Store is the recommended, I'd say, essential option. EBS provides durable block-level storage volumes that you can directly attach to a running EC2 instance. Think of it like a highly reliable, high-performance SSD or hard drive, specifically for your virtual server. It's not shared storage, it's block storage for that instance. It's designed precisely for those transactional workloads where data changes often and needs to be accessed really quickly, like your operating system drive or a database's primary storage files. Its key benefit, though, is its exceptional durability and reliability. EBS volumes are automatically replicated within the same availability zone. That's important within the AZ.
Right. Not across zones.
Correct. Within the AZ across multiple servers. This replication is totally transparent to you, and it prevents data loss from the failure of any single hardware component. In fact, AWS states that EBS volumes are designed to be 20 times more durable than typical commodity disk drives, which statistically have an annual failure rate, or AFR, of around 4%.
Wow, 20 times.
Yeah. So it means if you have, say, 1,000 EBS volumes running for a year, you should statistically expect only 1 or 2 to experience a failure. That level of built-in redundancy within an AZ provides significant peace of mind for mission-critical applications.
That's incredible durability, yeah. But even with durable storage, costs can definitely creep up if you're not careful. What are the best practices for optimizing EBS costs, especially since they're often tied so closely to EC2 usage?
Oh, EBS cost optimization is critical and often overlooked, big time. First, a common pitfall. You absolutely must delete any unattached EBS volumes. They continue to accrue charges even if the EC2 instance they were once connected to is stopped or even terminated.
Seriously, even if the EC2 instance is gone.
Yep. Think of it like leaving a rental car parked in a paid lot. After you've returned the keys, you're still getting charged for the parking space.
Okay, that's a huge one.
It is. Second, monitor your volumes. Use CloudWatch metrics to see how much they're actually being used. Then resize or change the EBS volume type for any that are underutilized. For example, if you provisioned a high-performance GP3 volume but your actual I/O needs turn out to be very low, you could potentially downgrade to a cheaper GP2 or maybe even an S1 throughput-optimized HDD volume, depending on the workload.
Makes sense.
And lastly, regularly check for and delete stale EBS snapshots. Snapshots are backups of your EBS volume stored in S3, and while they're essential for recovery...
Old ones just sit there costing money.
Exactly. If you have snapshots older than, say, 30 days that are no longer needed for recovery point objectives or compliance, get rid of them. They're just consuming S3 storage and adding to your bill. I actually worked with a company once that accidentally left a pretty large EBS volume unattached for nearly 6 months. That was a very, very expensive oops moment they really wish they'd known about these tips for.
Okay, so EBS is great for a single EC2 instance needing its own dedicated high-performance block storage. But what about a scenario where you need storage that many compute nodes, maybe dozens or even hundreds of EC2 instances, can access at high speeds all at the same time? Like maybe for a web application where all the web servers need to see the same pool of user-uploaded files, EBS won't work there, right?
Right, EBS is one-to-one. For that many-to-one scenario, you need Amazon EFS, or Elastic File System. EFS offers simple, scalable Elastic file storage. It's specifically designed for use cases requiring high throughput to multiple compute nodes simultaneously. Imagine a shared network drive, kind of like NFS if you're familiar with that, but one that's accessible to all your Linux-based EC2 instances at once, across availability zones within a region.
Ah, so it's inherently multi-AZ.
Yes, that's a key difference from EBS. EFS is a regional service.
It's incredibly easy to use, supports standard file system interfaces, and FSv4, so your applications often don't need modification. And its elasticity is a major selling point. It grows and shrinks automatically as you add or remove files on demand. So your applications always have the storage they need without you having to manually provision capacity or worry about running out of space. EFS is built for massively parallel shared access to thousands of Amazon EC2 instances, which is really powerful for use cases like content management systems, web serving farms, media processing workflows, or even shared development environments where multiple developers need access to the same code base. And as I mentioned, because it's a regional service, your data is stored redundantly across multiple availability zones within that region, providing excellent fault tolerance and high availability right out of the box.
Okay, moving on from block and file storage. Amazon S3 Simple Storage Service. It seems like it's everywhere in the cloud world. It's almost, synonymous with cloud storage for a lot of people. What are its core strengths? What's its unique architectural approach? And what are its most common uses? Yeah, S3 is definitely foundational. Amazon S3 Standard, the main tier, is really renowned for offering high durability, availability, and performance for frequently accessed data. Unlike block storage like EBS or file storage like EFS, S3 is object storage. This is a different paradigm. Think of it as storing entire files or objects, things like photos, videos, documents, backups, log files, each identified by a unique key or name. You don't manage servers or file systems here. You simply put objects into containers called buckets. That abstraction makes it an incredibly versatile service.
Right, no file systems to manage.
Exactly. It's suitable for a huge variety of use cases. Powering cloud-native applications, serving static content for dynamic websites like images or CSS, content distribution globally, backing mobile and gaming applications, storing data for big data analytics pipelines, and of course, storing backups or archives. Its durability is, well, it's truly exceptional. S3 is designed for 99.999999999%. That's 11 nines of durability for objects stored in a region.
11 nines. That sounds absurdly high. What does that actually mean in practice?
It is absurdly high. It means that if you store, say, 10 billion objects in S3 for a year, you would statistically expect to lose maybe one object. Maybe?
Wow.
The true insight here, I think, is that you can effectively stop worrying about your own backup strategy for the S3 objects themselves. AWS handles the built-in redundancy across multiple physical locations, multiple availability zones within a region automatically. That frees up immense time and resources, letting you focus on your core business, not on managing storage replication.
That level of durability is a huge benefit, for sure. Now, you mentioned website hosting as a use case. Can S3 host any kind of website, or are there limitations there? And relatedly, is it also suitable for things like databases? Seems unlikely given its object storage.
That's a really important clarification and definitely something to be clear on for the exam. You can host a static website on Amazon Simple Storage Service, Amazon S3.
Static only.
Static only. This means pages with HTML, CSS, JavaScript, images, videos, content that doesn't change based on user interaction or require server-side processing like PHP, Python, Java, etc. S3 does not support dynamic websites that require that kind of server-side scripting or database interactions. For those, you typically need a compute service like Amazon EC2, or maybe a serverless function like AWS Lambda connected to API Gateway.
Okay, got it. Static good, dynamic bad on S3.
Exactly. And regarding databases, you're absolutely right. S3 is an excellent storage facility for your media assets, your backups, your logs, because of its scalability, durability, and pay-as-you-go models, especially when paired with Amazon CloudFront for global content delivery network, CDN distribution. However, S3 is not suitable for databases. Why? Because it's object-level storage. It's designed for storing and retrieving whole objects, not for the kind of low-latency, random read-write operations and granular updates that databases require.
Right, databases need that block storage performance.
Precisely. Databases and dynamic websites typically need block-level storage, like EBS, which provides those necessary frequent and granular updates, or they run on dedicated database services like Amazon RDS or DynamoDB. Oh, and one more thing on S3. If you need to upload large amounts of data to S3, maybe from your data center, and you need it to go fast, look into S3 Transfer Acceleration. It optimizes the upload path by routing your data through AWS's global edge locations, which can significantly speed up transfers over long distances or less reliable networks.
Okay, networking. If I want to register a new domain name for my application like mynewapp.com, or critically ensure my users around the world are routed efficiently to the fastest possible server or AWS region for them, what's the AWS service for that, and how does it actually optimize performance?
For all things DNS and intelligent traffic routing in AWS, you're looking for Amazon Route 53. Route 53 is AWS's highly available and scalable domain name system, or DNS, web service. It's what you'd use for domain name registration, yes. But its primary function is translating those human-readable domain names, like example.com, into the numeric IP addresses that computers use to connect. Think of it as the Internet's highly reliable, scalable phone book.
Okay, so basic DNS lookups, but what about the performance optimization part, routing users to the nearest place?
Right. Route 53 plays a crucial role in improving application performance for a global audience by routing end users to the nearest AWS region to reduce latency. It achieves this using various routing policies, most notably its latency-based routing policies. So if your application is deployed in, say, both Ireland and Virginia, Route 53 can detect where a user is connecting from. A user in London would automatically be directed to the Ireland region, resulting in a much faster, lower latency experience than if they were sent across the Atlantic to Virginia.
Ah,
Furthermore, Route 53 also performs health checks on Amazon EC2 instances and other application endpoints. This is really important for fault tolerance. It can be configured to monitor the health of your servers or application endpoints. If a health check fails, say, server crashes, Route 53 automatically stops sending traffic to that unhealthy endpoint and reroutes it to healthy ones.
oh, wow. So it increases fault tolerance too.
Significantly. It ensures users are always directed to operational resources, even if an entire server, or sometimes even a whole data center availability zone, goes down.
Okay, last one in this section. What about someone who just needs a really simple, pre-configured virtual server without much fuss? Maybe for a quick WordPress blog, a small e-commerce site using something like Magento, or just a simple application. They don't want to deal with all the, intricate settings and configurations that come with setting up EC2, VPCs, security groups, EBS volumes separately. Is there an easier way?
Yes, definitely. For that specific need, where simplicity and ease of management are the absolute top priorities, Lightsail is the clear recommendation. It's often described as the easiest service to launch and manage a virtual private server, or VPS, primarily because it provides pre-configured virtual server instances. What Lightsail does is bundle together your compute, CPU, RAM, storage, SSD-based, and networking, data transfer allowance, into a single predictable low monthly price. You pick a blueprint, like WordPress, Node.js, Linux OS, choose a size, and click Launch. That's basically it.
So it abstracts away a lot of the underlying complexity.
Exactly. It makes it incredibly appealing for developers, students, or small businesses looking to get up and running really quickly without needing to dive deep into the complexities of EC2 instance types, VPC networking, subnetting, EBS volume types, and all that. The trade-off, of course, is that when it significantly simplifies things, you do give up some of the granular control, the wider range of instance types, and the advanced customization options available with the full power of EC2 and custom VPC configurations.
Makes sense. Good for simple stuff.
Yeah, it's a fantastic entry point for straightforward workloads where ease of use is paramount.
All right, let's shift gears to something that's always a hot topic in the cloud, cost management. It's not just about spending less, although that's nice. It's really about spending smarter, ensuring you get the most value for your investment. It's often a big, unpleasant surprise for new cloud users how quickly costs can escalate if they're not actively managed. So, what tools and strategies does AWS offer to help us visualize, understand, and actually plan our cloud costs effectively?
Yeah, this raises a super important question for any organization using the cloud. How do you actually get a handle on your spending and ensure efficiency? It's definitely not a set it and forget it kind of task. It requires continuous monitoring, ongoing optimization, and a really strategic approach. Unmanaged cloud spend can very quickly erode any of the perceived benefits of moving to the cloud in the first place. Hashtag tag AWS Cost Explorer. Okay, so for visualizing and managing your spending day-to-day, the AWS Cost Explorer is your primary tool, your go-to. It's an easy-to-use interface that lets you visualize, understand, and manage your AWS cost and usage over time. Think of it as your financial dashboard specifically for the cloud.
So charts and graphs of my spending.
Exactly. But it goes beyond just looking at historical data. Cost Explorer also offers powerful cost forecast capabilities. It actually uses machine learning to analyze your historical spend patterns and then forecasts your expected costs. It gives you daily forecasts for the next 3 months and monthly forecasts for the next 12
Oh,
months.
that's useful for budgeting.
Hugely helpful for planning and budgeting, yeah? It allows you to anticipate potential spikes or identify spending trends early. And by default, it provides several useful pre-built reports, like showing your top 5 cost accruing services so you know where the money's going, a detailed analysis of your overall EC2 usage, the total costs broken down by your member accounts if you use AWS organizations, and comprehensive reserved instance utilization and coverage reports, giving you immediate insights right out of the box. Hashtag consolidated billing in AWS organizations.
Right. Now, many companies, especially larger ones, operate with multiple AWS accounts, maybe for different departments or environments like dev, test, prod, or for security boundaries. Cost Explorer helps us see where the money's going across those accounts, but how do we actively save money, especially if we have multiple accounts and want to maximize volume discounts? What's the big benefit of consolidating billing, say, under a single master account using AWS organizations?
Yeah, that's where consolidated billing for multiple AWS accounts within the AWS organization service provides a really profound benefit. And it boils down to realizing combined usage for discounts.
Combined usage, how does that work?
Okay, so for billing purposes, the consolidated billing feature of AWS organizations essentially treats all the accounts in the organization as one account.
Ah, okay.
It's incredibly powerful because it means all accounts can receive the hourly cost benefit of reserved instances and also savings plans that are purchased by any other account within that same organization. So let's take a practical example. Let's say account A buys 5 EC2 reserved instances of a particular type, like M5.large, in a specific region.
Okay.
Now account B, which is in the same AWS organization, then uses 6 instances of that exact same type, M5.large, in the same region. Even though account B didn't buy any reserved instances itself, 5 of its instances will automatically be billed at the lower reserved instance rate because account A bought them. Only account B's 6th instance will be billed at the higher on-demand rate.
Wow, so the RIs are shared across the org.
Exactly. The benefit floats to where the usage is, up to the number of RIs purchased within the org. This aggregation helps maximize savings across your entire organization, ensuring those commitments are fully utilized. And beyond just billing, AWS organizations offer several other really important advantages for managing multiple accounts. It allows you to centrally manage access policies across all your AWS accounts using things like service control policies, SCPs, to set guardrails. You can automate AWS account creation and management for new projects or teams. You can control access to specific AWS services. You can configure AWS services consistently across accounts and even share common resources like VPCs, transit gateways, or custom AMIs.
So it's governance and management too.
Absolutely. These capabilities ensure a much more streamlined, secure, and governed cloud environment, significantly reducing management overhead, which also translates to cost savings indirectly. Hashtag savings plans.
Okay, so reserved instances are great if you know you'll be using a specific instance type or family for a year or 3. But what about other flexible pricing models? Especially if our compute usage spans different services, maybe EC2, but also Lambda serverless functions or Fargate containers, where predicting the exact instance type might be harder.
Yeah, that's where savings plans really shine. They represent a significant evolution in cost savings flexibility compared to traditional RIs. Savings plans are a flexible pricing model designed specifically to offer low prices on Amazon EC2, Lambda, Fargate, and Amazon SageMaker usage. In exchange, you make a commitment to a consistent amount of usage measured in hour for a 1-year or 3-year term.
So I commit to spend, say, $10 per hour, not to a specific instance.
Exactly.
Yeah.
That's the beauty of savings plans. Their flexibility across different compute services and configurations. You commit to a dollar amount of spend per hour, like your 10-hour example. Then, any eligible usage across those specified services, EC2, Lambda, Fargate, SageMaker, regardless of instance family, size, OS, tenancy, or even AWS region, up to your 10-hour commitment, is charged at the lower discounted savings plan's price. Any usage beyond that commitment is then simply charged at the regular on-demand rates.
Ah, I see. So the discount travels with my usage.
Precisely. This allows for much greater flexibility than traditional reserved instances because your discount applies automatically to different types of compute usage. It's ideal for dynamic workloads where instance types might change while still providing significant cost savings, similar to RIs, for that predictable baseload of usage. Hashtag right-sizing your resources.
Okay, choosing the right pricing model like RIs or savings plans is one part of saving money, but it's also fundamentally about making sure the resources we provision the EC2 instances, the databases actually fit the need, right? Over-provisioning seems like a really common and expensive mistake in the cloud.
Oh, absolutely. Right-sizing is critical. It's a cornerstone of cloud cost optimization, and it's often where the biggest savings can be found initially. It's defined simply as matching instance types and sizes to your workload performance and capacity requirements at the lowest possible cost. And this process is crucial both before and after migration to the cloud. By right-sizing before you migrate, you can significantly reduce your initial cloud infrastructure costs. You avoid the trap of just lifting and shifting potentially oversized on-premises servers directly into equally oversized and therefore extensive cloud instances.
Right, don't just replicate the old environment's waste.
Exactly. If you skip that step, you might accelerate the migration timeline slightly, but you could end up incurring substantially higher cloud infrastructure spend for a long, long time. And because your resource needs are dynamic, they change over time. Right-sizing needs to be an ongoing process. It's about continuous cost-performance optimization. For instance, when you're choosing an Amazon RDS database instance, you'd ideally analyze its actual CPU utilization, disk I/O patterns, and memory usage over time, and then pick the instance family and size that most closely matches those needs, rather than just picking the largest one available just in case.
Use the data to make the choice.
Use the data. AWS provides a huge selection of instance types and sizes, precisely to give you the flexibility to right-size your resources effectively. Picking the right size can prevent unnecessary overspending, often saving hundreds or even thousands of dollars per month per instance just by dropping down a size or changing to a more appropriate instance family. #tagging strategy.
Now, as organizations grow and use more and more AWS resources across different teams and projects, keeping track of costs across all those different initiatives can become a real headache. How can they manage this effectively? How do they ensure accountability and get clarity on who's spending what?
This is where having a robust tagging strategy becomes absolutely invaluable. It's often referred to specifically as cost allocation tagging. Tags, fundamentally, are just simple key value pairs that allow you to organize your AWS resources into logical groups. Think project, blue or environment, production or cost center. 1, 2, 3, 4, 5.
Simple labels, basically.
Simple labels, yeah. But by implementing a clear and consistent tagging strategy across all your resources, you gain significant benefits, especially for cost management. You can track usage and spending across different departments, department.marketing, specific applications, application website, or environments, dev, environment, test, environment, prod. This allows you to visualize information about tagged resources easily within Cost Explorer. You can filter your spending views based on these tags. You can view detailed billing information broken down by tag in your monthly bill or in cost and usage reports. And you can even use tags to create separate invoices or cost reports for each project or work environment, enabling chargeback or showback internally.
So it enables that financial tracking.
Absolutely. It's recommended to use logical groupings for your resources that make sense for your infrastructure or your business structure. Common useful tags include project, environment, cost center, application, or department. This seemingly simple practice provides granular visibility into your spending, which is absolutely crucial for accountability, for identifying optimization opportunities, and for ongoing cost control. Without a good tagging strategy, your AWS bill can quickly become a really large, unreadable mystery. #tag AWS pricing calculator.
Okay, so we've talked about tracking costs once resources are running, but before even launching a single resource, it seems wise to get an idea of what the potential costs might look like. How can I get a reliable estimate of my potential AWS bill, and what can that estimate help me discover?
Yeah, planning ahead is key. Before any significant deployment, you should definitely use the AWS pricing calculator. This is a free, web-based tool provided by AWS, designed specifically to help you estimate your monthly AWS bill more efficiently and transparently. It's extremely useful for determining best and worst case scenarios for different configurations and anticipated workloads.
So I can model different options.
Exactly. You can model different instance types, storage amounts, data transfer volumes, etc. And crucially, it helps identify potential areas for cost reduction before you commit to launching resources. Maybe using a different region is cheaper, or a different storage tier. You can input your anticipated usage for various services, EC2 instances, S3 storage amounts, RDS database types, network egress traffic, and it will provide a detailed, itemized estimate. The calculator is continuously updated by AWS with the latest pricing for all their services across all public regions, ensuring your estimates are as accurate as possible, which is vital for planning budgets and, frankly, for gaining approval for cloud projects internally. #tag economies of scale.
We often hear this phrase, economies of scale, thrown around in cloud computing discussions as a major advantage. What does that actually mean for us, the customers? How does AWS being huge translate into real-world cost benefits for me?
Yeah, economies of scale is a fundamental economic principle that massively benefits cloud users. What it means for you, the customer, is that AWS will continuously lower costs as it grows.
How does that work?
Because AWS aggregates usage from literally hundreds of thousands, probably millions, of customers globally. They achieve a massive scale of operations, buying servers, building data centers, negotiating power contracts that individual organizations simply cannot match on their own. This huge scale allows providers like AWS to achieve much lower variable costs for things like hardware, electricity, cooling, bandwidth, you name it. This efficiency gain is then passed directly on to customers in the form of lower pay-as-you-go prices over time.
So they get cheaper and we pay less.
That's the idea. A great classic example of this is Amazon S3. The per gigabyte storage price for S3 Standard has been reduced by over 80% since the service was first introduced way back in 2006.
Wow, 80%.
Yeah, that's a direct, tangible benefit of these massive aggregated economies of scale. It makes cloud services increasingly affordable over time, often without you having to do anything specific other than just keep using the service.
Okay, shifting from the financial side of things now to security, which is, well, arguably even more critical and often top of mind for anyone considering or using the cloud. How do we actually manage who can access what in our AWS environment? And how do we protect our network traffic from unauthorized access or potentially malicious attacks?
Yeah, this raises a really important question about fundamental control and protection in the cloud. Security, as we know, is famously a shared responsibility between AWS and the customer, but our part as customers is incredibly significant. Understanding these core security, identity, and networking services is absolutely vital for maintaining a strong security posture, which is just non-negotiable for any organization today. Hashtag identity and access management, IAM. All right, so at the very heart of access control in AWS is AWS IAM, which stands for Identity and Access Management. This service is what enables you to manage access to AWS services and resources securely. It's the gatekeeper, essentially. With IAM, you create and manage AWS users, which can represent actual people or application services that need access. You can organize these users into logical user groups, maybe based on job function, and then critically, you use permissions defined in IAM policies to explicitly allow or deny their access to specific AWS resources or actions. Can this user terminate an EC2 instance? Can that application read from an S3 bucket?
So it's all about fine-grained permissions.
Exactly. It's how you define who can do what within your entire cloud environment, adhering to the security best practice principle of least privilege, giving entities only the permissions they absolutely need to perform their tasks, and no more. You can also create IAM roles, which are super important. Roles provide temporary credentials that applications running on EC2 or AWS services themselves, or even users from other accounts, can assume to gain specific permissions for a limited time without needing long-term access keys.
Okay, there's a specific term I've seen, IAM identity. Can you assign that directly to a user? It kind of sounds like it should be something you can directly manage or assign.
That's a great question for clarification, and yeah, it can be a common point of confusion. The short answer is no. You cannot directly assign an IAM identity to a user.
Why not?
Because IAM identity is a more generalized term referring to any entity in IAM that can be authenticated and authorized. This category includes specific things like IAM users, IAM groups, or IAM roles.
So identity is the category, not the specific thing.
Exactly. Think of IAM identity as a broad category, maybe like types of people who can interact with AWS. You don't assign someone the label type of person. You assign them a specific role or status within that category, like IAM user for a person requiring long-term credentials, or an IAM role for an AWS service needing permissions, or for temporary access that can be assumed. So, in practice, you're always working with concrete IAM entities, users, groups, roles, policies, not the abstract concept of an identity itself.
Okay, now what if a company has, say, multiple AWS accounts, maybe dozens or hundreds, and they also use other common business cloud applications, things like Salesforce or Microsoft 365? They definitely want to simplify how their employees access all these different systems, ideally with a single login, right? Managing all those passwords would be a nightmare.
Oh, absolutely. Managing multiple sets of login credentials across various platforms quickly becomes a huge operational burden for IT and a major frustration and security risk for employees. This is exactly where AWS IAM Identity Center, which was formerly known as AWS Single Sign-On or AWS SSO, provides a really powerful solution. It acts as a central place to manage user access, enabling single sign-on access to all assigned accounts and applications from one place.
So one login for everything.
Pretty much, yeah. This means your workforce can log in once, perhaps using their existing corporate directory credentials, like from Active Directory or Okta, and then securely access all their assigned AWS accounts and other connected business applications that support the Security Assertion Markup Language, or SAML 2.0 standard, without needing separate passwords.
Nice.
It significantly streamlines identity management for administrators, improves the end-user experience by reducing that dreaded password fatigue, and fundamentally enhances security by consolidating authentication points and reducing the overall attack surface associated with multiple credentials.
Okay, shifting focus slightly to network security now. How do we actually filter incoming and outgoing traffic to our EC2 instances? What are the fundamental mechanisms in place at the network layer to control who can talk to whom? And maybe related, what about protection against large-scale network attacks like DDoS?
Right. For foundational network filtering and controlling traffic flow to and from your resources within your VPC, virtual private cloud, both NACLs and security groups are crucial. They operate at different levels and provide a sort of layered defense.
Okay, what's the difference?
Security groups act as a stateful virtual firewall for your instances. They control inbound and outbound traffic right at the elastic network interface, ENI level of an EC2 instance or RDS instance, etc. Stateful means they remember previous connections. So if you allow outbound traffic on port 80, the return traffic coming back from that connection is automatically allowed, regardless of inbound rules. Think of a security group as a personal bodyguard standing right next to your server.
Okay, instance level stateful. What about NACLs?
NACLs, or Network Access Control Lists, operate at the subnet level within your VPC. They act as a stateless firewall for controlling traffic in and out of one or more subnets. Stateless means they don't remember previous connections. They process rules in order, based on rule number, and you must explicitly define rules for both inbound and outbound traffic. If you allow inbound traffic on port 80, you also need a separate outbound rule to allow the response traffic back out on the appropriate ports. Think of NACLs as the security guard controlling access to an entire floor or section of a building, the subnet.
Subnet level, stateless, got it.
So you have two layers of firewall control there. Now, while security groups and NACLs are absolutely essential for basic network-level traffic control, and they can certainly help mitigate some very basic network-level attacks by blocking unwanted ports or IPs, for dedicated protection against large-scale distributed denial of service, DDoS attacks, you typically look to specialized AWS services like AWS Shield Standard, which is free and automatically enabled, or AWS Shield Advanced, a paid service for enhanced protection, and potentially AWS Web Application Firewall.
Right, those are for the bigger attacks.
Exactly. Security groups are like your personal firewall. AWS Shield is more like the entire stadium security team, designed specifically for handling massive, coordinated volumetric or application layer attacks. Oh, and specifically, when we talk about securing Amazon RDS database instances, it's important to remember that security groups are used to control which IP address ranges or other security groups can connect to your databases. This is how you restrict network access to your sensitive database instances, allowing connections only from trusted sources like your application servers, a critical security measure for any database workload.
Okay, let's talk hybrid cloud. For organizations that need to securely connect their existing on-premises networks, their corporate data centers to their AWS cloud environment, maybe for extending their network or migrating applications gradually, what's the go-to service for that? And what technology does it use to create that secure, private connection over the public internet?
Right. Establishing that secure bridge between on-premises and AWS is a very common requirement. When you need to establish secure connectivity between your on-premises network and your AWS VPC over the public internet, AWS Site-to-Site VPN is the service you'll typically use first. It specifically uses Internet Protocol Security, IPsec, to establish encrypted connectivity.
IPsec.
Wow.
Yes, IPsec is a well-established protocol suite that secures IP communications by authenticating and encrypting each IP packet of data that travels between your on-premises VPN gateway, like a router or firewall, and the AWS VPN gateway on the VPC side. This ensures that your data remains confidential, encrypted, and maintains its integrity, hasn't been tampered with, as it traverses the potentially insecure public internet. It's a fundamental component for building robust hybrid network architectures, allowing you to securely extend your corporate network into your Amazon Virtual Private Cloud, VPC, without needing to rely on potentially more expensive, dedicated private lines like AWS Direct Connect, at least initially.
Now, what if a company has really grown significantly in the cloud? Maybe they've deployed hundreds of VPCs, perhaps across multiple AWS regions, and they're finding that managing all those individual VPC peering connections between them is becoming incredibly complex, like a tangled mess, and really difficult to scale. Is there a service designed to simplify this intricate web of interconnectivity?
Oh yeah, managing a sprawling network of VPCs using just individual VPC peering connections can indeed become a real management nightmare. You end up with what's often called a mesh topology, and the number of connections goes exponentially as you add more VPCs. It's very hard to manage routing and security policies consistently.
Sounds messy.
It is. That's precisely the problem that AWS Transit Gateway was developed to solve. It acts as a highly scalable network transit hub that simplifies how customers interconnect all of their VPCs and also their on-premises networks via VPN or direct connect attachments within and across regions. Instead of creating that complex mesh of point-to-point peering connections between every single VPC, Transit Gateway enables a much cleaner hub-and-spoke model.
Hub and spoke.
Yes, each VPC or your on-premises network connection simply connects, or attaches, to the central Transit Gateway, the hub. The Transit Gateway then acts as a central router, intelligently routing traffic between all the connected spokes based on route tables you configure. This approach significantly reduces operational costs and complexity compared to managing hundreds of peering connections. And it makes it incredibly easy to scale your network as your business grows, because any new VPC you create simply needs to connect to the Transit Gateway, and it instantly gains connectivity to everything else attached to that hub. It truly simplifies network architecture and management for complex, multi-VPC, multi-region environments.
Okay, let's talk encryption keys. Encryption is absolutely paramount for data protection, both for data sitting still at rest and data moving across networks in transit, especially to meet compliance regulations and general security best practices. How does AWS help us manage our encryption keys securely and efficiently across all the different AWS services we might be using? And does it offer different levels of control over those keys?
That's a critical area. AWS offers two primary distinct services for managing encryption keys, and they cater to different levels of control and compliance needs. Understanding the difference is key. First, there's AWS Key Management Service, KMS. This is a fully managed service that makes it really easy for you to create and control the encryption keys used to encrypt your data across a wide range of AWS services. KMS uses FIPS-140-2 Validated Hardware Security Modules, or HSMs, under the hood to protect the security and integrity of your keys.
FIPS 140-2, what's that?
FIPS-140-2 is a U.S. government security standard for cryptographic modules. Being validated means the HSMs AWS uses have undergone rigorous independent testing to ensure they meet these stringent security requirements for protecting keys. It's basically the gold standard for cryptographic key protection, ensuring that the keys are generated, stored, and used securely, and that even AWS personnel cannot access your keys in plain text when they are managed by KMS.
Okay, so high security, managed by AWS.
Right. KMS is deeply integrated with most other AWS services like S3, EBS, RDS, Lambda, allowing you to easily encrypt data stored within those services using keys managed in KMS. It also integrates tightly with AWS CloudTrail, which provides detailed logs of all key usage, who use which key when on what resource, which is essential for auditing and compliance purposes. Now, for customers who require an even greater level of control over their encryption keys, perhaps due to very stringent regulatory requirements like certain financial or government regulations or specific corporate security policies, AWS Cloud HSM is the alternative. Cloud HSM provides a cloud-based hardware security module, HSM, that enables you to generate and use your own encryption keys on dedicated single-tenant HSM appliances hosted within AWS data centers. It offers FIPS 140-2 Level 3 validated HSMs, which represents an even higher level of security assurance and tamper resistance than the Level 2 used by KMS. With Cloud HSM, you maintain exclusive single-tenant control over your keys within these dedicated HSMs. No one else, not even AWS, can access or manage your keys on your behalf.
So I have full control, but I also have to manage it more.
Exactly. You manage the keys directly using industry-standard APIs like PKCS-11, Java Cryptography Extensions, JCE, or Microsoft Crypto NG, CNG libraries. The key distinction really boils down to the level of control and responsibility. KMS is a managed service offering high security with ease of use and integration, while Cloud HSM provides dedicated single-tenant hardware giving you maximum control, but also requires more management effort on your part.
Okay, so we've got our resources provisioned, we've secured them, we're managing costs. The next big challenge really is keeping everything running well day to day and knowing you can get help when inevitably something goes wrong or you have a question. Let's talk about the operational side of things, how AWS helps us maintain a healthy, performant, and reliable environment, and what support options are available.
Yeah, and the broader implication here, connecting this to the well-architected framework, which we'll touch on, is that operational excellence is about way more than just keeping the lights on. It's really about striving for continuous improvement, gaining proactive insights into how your systems are behaving, and having the right tools and support structures in place to deliver business value consistently and reliably. It's a mindset of constant refinement and preparedness, which is absolutely vital for sustained success in the cloud. Hashtag AWS support plans.
Right. Now, different businesses obviously have vastly different support needs. A small startup running a non-critical dev environment has different requirements than a large enterprise running mission-critical production workloads. What are the key AWS support plans available? And maybe more importantly for the exam, what specific services or levels of access are exclusive to certain tiers? Where do the lines get drawn?
That's a very practical question. AWS offers a tiered support model designed precisely to meet those diverse needs. The main plans are Basic, which everyone gets for free, Developer, Business, and Enterprise. It's really crucial for anyone preparing for the Cloud Practitioner exam to understand the key differences and what each provides, as questions often test this. For instance, a common differentiator is access to real-time help. Live chat support is only available with Business or Enterprise support plans. If you're on a Basic or Developer plan, that chat option simply won't be available on the console. Your support options there are primarily through documentation, forums, and limited email support for account billing issues, basic or technical issues during business hours. Developer.
Okay, so chat needs business or enterprise.
Correct. Furthermore, the highly specialized AWS Support Concierge service, which provides dedicated senior support personnel acting almost like a liaison for your account, helping with billing inquiries, account management, and navigating AWS resources that's exclusive only to the top-tier enterprise plan. Now, for anyone running actual production workloads on AWS, the business support plan is generally the strongly recommended minimum. Why? Because this plan provides 24/7 access to technical support via phone, chat, and email, crucially with defined response time service level agreements, SLAs. For example, you get a guaranteed response in less than 1 hour for a production system down issue. That rapid response can be critical.
Yeah, 1 hour versus potentially much longer makes a big difference.
Huge difference. Business support also includes architectural guidance from AWS solutions architects, access to the full set of AWS Trusted Advisor checks, not just the limited core checks and basic developer, and AWS Health Dashboard access with API integration capabilities for tying it into your existing operational monitoring systems. Additionally, business support grants access to things like the AWS Support API for programmatic case management and access to proactive support programs like AWS Countdown. Countdown provides dedicated architectural and scaling guidance leading up to planned high-traffic events like product launches or marketing campaigns, although Countdown itself is often an additional fee unless you have enterprise support where it's included.
Okay.
So choosing the right support plan is really about honestly assessing your business criticality and aligning that with the required level of support responsiveness and proactive guidance.
Okay, besides reactive support, how does AWS help us proactively stay on top of our environment? Monitoring its current health, checking its security posture, making sure we're actually adhering to AWS best practices. It's not always easy to know what you don't know, especially in a dynamic cloud environment that's constantly changing.
Right. Proactive monitoring and adherence to best practices are key to operational excellence. AWS provides a whole suite of services designed for precisely that, and they often work best when used together. First up is AWS Trusted Advisor. This is an incredibly valuable online tool that provides real-time guidance to help you provision your resources according to AWS best practices. Think of it like an automated cloud consultant constantly scanning your account. It checks across 6 critical categories: cost optimization, like identifying idle resources; security, finding overly permissive security groups or exposed access keys; fault tolerance, checking things like backup status or AZ distribution; performance, looking for underutilized resources; operational excellence, new checks being added here; and service limits, warning you if you're approaching quotas.
So it gives specific recommendations.
Yes, specific actionable recommendations. For instance, it actively improves security by identifying and helping you close common security gaps, suggesting enabling various AWS security features you might have missed, and examining your IAM permissions for potential vulnerabilities like unused access keys. Then there's AWS Health, which used to be called the Personal Health Dashboard, or PHD. This is the single place to learn about the availability and operations of AWS services that are relevant to you. It offers a personalized view of service health. Instead of just seeing a global status page saying S3 is green, AWS Health shows you the status of the specific AWS services powering your applications in the regions you use.
Much more relevant.
Much more relevant. You also get proactive notifications through AWS Health for things like upcoming planned AWS hardware maintenance activities or software updates that might affect your specific resources, giving you time to prepare. It also provides detailed troubleshooting guidance during broader service events, often including recommended remediation steps and lists of your potentially affected resources. Now, to illustrate how these work together with other services, imagine Trusted Advisor flags a high-risk security group rule that allows unrestricted access from the internet.
Okay.
AWS Config could then show you exactly when that misconfiguration occurred and potentially who made the change, because AWS Config is designed to continually monitor for compliance or vulnerabilities by recording all configuration changes made to your AWS resources over time. It provides that audit trail. This allows for effective point-in-time analysis and period-in-time audits of your configuration history.
I see. So config tracks the changes.
Exactly. Meanwhile, Amazon Inspector focuses specifically on automated security vulnerability assessments. It scans your running EC2 instances for known software vulnerabilities, CVEs, and unintended network exposure based on network reachability analysis.
Okay, so inspector looks inside the instance more.
Primarily, yes, for vulnerabilities, and also analyzes network paths to the instance. And then AWS Health would be the place to check if there are any broader AWS service incidents happening in your region that might be impacting things, or if that hardware maintenance notification explains a performance dip. So together, Trusted Advisor, AWS Health, AWS Config, and Amazon Inspector provide a powerful and comprehensive view of your cloud environment's health, security posture, compliance status, and adherence to best practices. AWS Well-Architected Framework Operational Excellence Pillar.
You mentioned the well-architected framework. It seems incredibly important for anyone designing or operating systems on AWS. It's like a guidepost for architects, right? What does the operational excellence pillar specifically entail within that framework? What are its key principles or ideas?
Yes, the AWS Well-Architected Framework is absolutely fundamental. It provides a consistent approach for customers and partners to evaluate architectures and implement designs that will scale over time. It's built on 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. The operational excellence pillar, specifically, is defined by AWS as the ability to run workloads effectively, gain insight into their operations, and to continuously improve supporting processes and procedures to deliver business value. It's really about optimizing your daily operations to ensure you can consistently deliver and improve your workload's functionality and meet business goals. This pillar is guided by several key design principles which are worth knowing. 1. Organize teams around business outcomes. Structure your teams to own services and focus on delivering specific business value, not just managing siloed infrastructure components. Foster a business-aligned operating model. 2. Implement observability for actionable insights. This is huge. Instrument your workloads thoroughly to gain deep insight into their behavior, performance, and health. Use key performance indicators, KPIs, metrics, logs, and traces to understand what's happening and why.
More than just basic monitoring.
Much more. 3. Safely automate whenever possible. Define your entire workload applications, infrastructure, configuration, deployment pipelines, operational procedures as code. This limits human error, enables repeatable and consistent deployments, and allows for faster changes. Infrastructure as code is key here. 4. Make frequent, small, reversible changes. Instead of large, infrequent, risky deployments, aim for small, incremental updates that can be easily rolled back if something goes wrong. This minimizes the blast radius of potential failures and allows for faster iteration.
Agile principles, basically.
Very much so. 5. Refine operations procedures frequently. Continuously improve your operational runbooks and processes as your workload evolves and as you learn from operational events. Keep documentation up to date. 6. Anticipate failure. Proactively think about how things could fail. Use techniques like pre-mortem exercises, where you imagine a failure and work backward to prevent it, and conduct regular game days to simulate failures and test your team's response procedures. Build resilience by assuming things will fail eventually.
Practice for failure.
Exactly.
Okay.
7. Learn from all operational events and metrics. Use every incident, every alert, every performance deviation as an opportunity for learning and improvement. Drive a culture of continuous learning and blameless postmortems. 8. And finally, use managed services to reduce operational burden. Leverage AWS managed services like Amazon RDS, AWS Lambda, or Amazon SQS whenever appropriate. Let AWS handle the undifferentiated heavy lifting of managing the underlying infrastructure, patching, scaling, backups, allowing your teams to focus on activities that differentiate your business.
Right. Focus on what matters most to the business.
Precisely. These principles together help ensure your cloud operations are efficient, effective, resilient, and continuously improving over time.
Okay, now what if an organization needs more hands-on expert help? Perhaps they're navigating a really complex cloud migration, or they need to optimize a critical high-performance workload, or maybe they're trying to achieve very specific strategic business outcomes using AWS. They might need more than just standard support or automated tools. Is there an option for that?
Yes, for those situations where deep expertise and tailored guidance are required, AWS Professional Services, often called ProServe, is the answer. This is a global team of experts employed by AWS that helps customers realize their desired business outcomes when using the AWS cloud. They essentially supplement your internal teams with specialized skills and extensive experience drawn from working with thousands of customers. They offer things like strategic advisory, architectural guidance, hands-on implementation support for specific projects, and help with organizational change management related to cloud adoption.
So they're like AWS consultants.
Exactly. Think of them as high-level consultants and implementation specialists who come in to accelerate your journey, helping customers gain sustainable business advantages by leveraging AWS services optimally and overcoming specific challenges. They work on defined projects or engagements.
Now, for organizations just starting their migration journey to the cloud, or perhaps those looking to optimize their overall cloud strategy and ensure a more holistic transformation across the business, not just IT, I've heard about the AWS Cloud Adoption Framework, or CF. Does that provide a structured roadmap or guidance?
Yes, the AWS CF is an incredibly valuable framework and methodology. It leverages AWS's extensive experience and documented best practices gathered from helping thousands of organizations migrate to and operate in the cloud, aiming to accelerate digital transformation and reduce business risk. It's typically built around helping organizations understand and plan their cloud adoption journey, often involving a structured four-phase process: envision, align, launch, and scale.
Envision, align, launch, scale. Okay.
Right. The vision phase is about understanding how the cloud can help accelerate specific business outcomes and create tangible value. Align focuses on identifying capability gaps within the organization, technical, process, people, and creating strategies to improve overall cloud readiness. Launch involves delivering initial pilot initiatives in production, demonstrating incremental business value, and capturing key learnings. And the scale phase is about expanding those successful pilots to full production scale, ensuring sustained business benefits and driving continuous improvement. Crucially, the AWS CF also defines 6 perspectives that need to be considered for a successful transformation: either business, people, governance, platform, security, and operations.
6 perspectives covering
Yeah.
the whole organization.
Pretty much. Each perspective comprises a set of key capabilities that functionally related stakeholders, like finance, HR, security teams, infrastructure teams, own or manage in the cloud transformation journey. For example, the business perspective focuses on things like IT finance, cost management, and measuring business value. The people perspective covers roles, skills, training, and organizational change management. The security perspective deals with identity management, detective controls, infrastructure security, data protection, etc. This comprehensive framework provides guidance that helps improve cloud readiness across the entire organization, ensuring that it's not just a technical shift, but a broader business transformation. Hashtag managing your service limits. Quotas.
It's probably easy to forget, especially with the promise of near infinite scale in the cloud, that there are still actual limits to everything. Even with AWS, we can't just spin up, say, 10,000 EC2 instances instantly without hitting some kind of ceiling, can we?
That's a critical point, yeah, and one that new cloud practitioners absolutely must be aware of, as it can bite you unexpectedly. Service limits, which are also increasingly called service quotas in AWS documentation, are essentially the maximum number of service resources or operations that apply to an AWS account by default.
Why do they have these limits?
AWS maintains these limits primarily for 2 reasons. First, to guarantee the availability and stability of resources for all customers sharing the underlying infrastructure. And second, to help minimize billing risks for customers from accidental or malicious over-provisioning. Imagine if someone accidentally scripted launching 1 million instances, the bill could be astronomical.
Good point. Okay.
So continuous monitoring of these limits, especially as your usage grows, is incredibly important. One of the easiest ways to keep an eye on them is via AWS Trusted Advisor's Service Limit Dashboard, which provides a clear, centralized overview of your current usage against the default quotas across various services and regions. Now, while some quotas might be raised automatically by AWS over time, As you use the platform and demonstrate good standing, most services require that you proactively request quota increases manually when you anticipate needing more capacity. This process is typically managed through the Service Quotas console in AWS or via the AWS CLI SDK.
So I have to ask for more.
Usually, yes. Planning for these quota increases in advance, especially before large-scale deployment, application launches, or anticipated high-traffic events, is crucial to avoid hitting unexpected roadblocks, where you suddenly can't launch more instances or create more resources when you need them most.
Okay, last operational point. For reasons like auditing, meeting industry compliance standards, like healthcare or finance, or handling legal agreements, how can I access AWS's own official compliance documents? Things like their ISO certifications or SOC reports, or maybe even manage specific agreements like a Business Associate Addendum, BAA, required for HIPAA compliance.
For all your official AWS compliance and agreement documentation needs, the service to remember is AWS Artifact. It's essentially a self-service audit artifact retrieval portal, available directly in the AWS console. It provides customers with on-demand access to AWS's key compliance documentation and reports. This includes critical reports like AWS ISO certifications, e.g. ISO 27001 for security management, payment card industry, PCI, DSS attestation of compliance reports for handling credit card data, and system and organization control SOC reports SO1, SOC2, and SOC3, which provide detailed third-party auditor assessments of AWS's security, availability, and operational controls.
So I can just download those directly.
Yes, you can download them directly after accepting terms, which is often necessary for audit purposes. You can also use AWS Artifact to review, accept, and track the status of specific AWS agreements relevant to your business or compliance needs. A key example is the Business Associate Addendum, or BAA, which is essential for healthcare organizations or their partners who need to handle protected health information, PHI, on AWS in compliance with ABA regulations.
Okay.
So think of AWS Artifact as your central authoritative self-service hub for accessing all official AWS compliance reports and managing relevant agreements. ## historical billing information. Oh, and just a quick practical note for anyone wondering where to find their old bills or detailed spending history. Historical billing information can always be found and downloaded from the Billing and Cost Management console within your AWS account. That's the central repository for all your PaaS invoices and detailed usage breakdowns.
All right, let's move beyond the traditional view of the cloud as just virtual machines. The cloud today is also hugely about innovative ways to build applications and process data, often without managing any servers directly, which is a massive paradigm shift. Let's look at some of these potentially game-changing services that enable more modern application architectures and really powerful data analytics capabilities.
Yeah, what's truly fascinating here, I think, is how AWS increasingly empowers engineers and developers to focus almost entirely on their application logic and delivering business features, rather than spending time on the undifferentiated heavy lifting of provisioning, patching, scaling, and managing the underlying infrastructure. This shift enables entirely new architectural patterns and approaches to solving problems, often leading to solutions that are more agile, more scalable, more resilient, sometimes even more cost-effective for a wide range of modern use cases.
Okay, the term serverless comes up constantly now, alongside containers, which are also incredibly popular for packaging applications. What exactly does AWS Fargate offer in this space? How does it fit in with container orchestration services like ECS and EKS? It can seem a bit confusing.
Yeah, let's try to clarify that. AWS Fargate is a prime example of serverless compute, but specifically designed for running containers. You can think of it as a serverless compute engine for deploying and managing containers. What serverless means here is that Fargate completely frees users from having to provision, configure, scale, or manage the underlying cluster of virtual machines, EC2 instances, that would normally be needed to run containers.
So no EC2 instances to manage at all.
None whatsoever when you use Fargate. You simply package your application into a container image, like a Docker image, define how much CPU and memory it needs, upload it to a registry, and then tell Fargate to run it. Fargate handles finding the capacity, launching the container, managing its lifecycle, and scaling it. You don't see or manage any servers. Fargate seamlessly integrates as a launch type or compute option with both of AWS's main container orchestration services, Amazon Elastic Container Service, ECS, and Amazon Elastic Kubernetes Service, EKS.
Okay, so Fargate runs the containers. What are ECS and EKS then?
Right. ECS and EKS are the orchestrators. They manage the deployment, scaling, and networking of your containers at scale. Amazon Elastic Container Service, ECS, is AWS's own proprietary, highly scalable, high-performance container orchestration service. It deeply integrates with other AWS services and is generally considered easier to get started with if you're already heavily invested in the AWS ecosystem. It supports standard Docker containers. Amazon Elastic Kubernetes Service, EKS, on the other hand, is AWS's managed service that allows you to run Kubernetes on AWS without needing to install, operate, and maintain your own Kubernetes control plane. Kubernetes itself is a popular, powerful open-source system for automating deployment, scaling, and management of containerized applications. EKS provides a conformant upstream Kubernetes experience.
So EKS is managed Kubernetes. ECS is AWS's own orchestrator.
Exactly. And for both ECS and EKS, you have choices for where your containers actually run the compute layer. You can run them on AWS Fargate for that fully serverless, hands-off experience we just discussed. That's often the simplest option. Or you can choose to run your containers on regular EC2 instances that you manage within your account. You do this if you need more granular control over the underlying operating system, specific instance types like GPU instances or networking configurations. And now there are even options like ECS Anywhere and EKS Anywhere, which allow you to use the same AWS orchestration tools, ACS or EKS, to manage containers running on your own on-premises virtual machines or physical servers, extending that consistent container management experience to your hybrid cloud environment.
Okay, let's talk about application architecture. For organizations maybe dealing with older legacy monolithic applications, those big, tightly coupled systems where everything runs as one unit, which can be rigid, hard to update, and difficult to scale specific parts of. How can AWS help us break those down into more flexible, loosely coupled components like microservices to improve agility and resilience?
Yeah, this is a very common architectural challenge and a major driver for cloud adoption, modernizing those monoliths. AWS provides several excellent messaging and eventing services specifically designed to facilitate this shift from tightly coupled monolithic architectures to more flexible, independent, loosely coupled microservices. Just quickly, monolithic applications, as you said, are often self-contained and highly interdependent. A failure or a spike in demand in one small part can impact the entire system, and scaling often means scaling the whole monolith, which can be inefficient and costly. Microservices, conversely, break the application down into smaller, independent services, each performing a single business function. They communicate typically over a network, often using messaging services. This loose coupling allows for independent updates, deployment, technology choices, and scaling for each microservice, dramatically improving agility and resilience.
Right, scale just the part that needs it.
Exactly. So how do we connect these microservices reliably? AWS offers a few key services here. One, Amazon Simple Queue Service, SQS. This is a fully managed message queuing service. Think of SQS like a highly reliable, durable, and scalable digital mailbox or buffer between two specific applications or microservices. One service, the producer sends a message, for example, process this new order, into an SQS queue. Another service, the consumer, pulls messages from the queue to process them at its own pace.
So it decouples them in time.
Precisely. SQS ensures guaranteed delivery of the message, even if the consumer service is temporarily unavailable or busy. It acts as a shock absorber, smoothing out traffic spikes and ensuring no messages are lost. It's perfect for decoupling microservices that need reliable point-to-point asynchronous communication, providing a durable buffer and enabling high throughput and resilience. 2. Amazon Simple Notification Service, SNS. This is a fully managed publish-subscribe messaging service, often called PubSub. Think of SNS like a broadcast mechanism or a megaphone. A producer sends a message once to an SNS topic. Then all interested subscribers that are signed up to that topic receive a copy of the message immediately.
One message goes to many places.
Yes, exactly. Subscribers can be various things: AWS Lambda functions, SQS queues, HTTPS endpoints, email addresses, even mobile push notifications. SNS is great for fan-out scenarios where a single event, like a new user sign-up, needs to trigger multiple different actions simultaneously across your system. 3. Amazon EventBridge, which evolved from CloudWatch Events. This is a serverless event bus service that makes it easy to build sophisticated event-driven architectures. Think of EventBridge as your smart central nervous system for handling events flowing through your application and even from external sources.
How is it different from SNS?
It's more powerful for complex routing and integration. EventBridge can receive events from a huge number of sources, not just your own applications, but also directly from over 200 AWS services, and even from dozens of third-party SaaS applications like Zendesk, Shopify, PagerDuty, through native integrations. Then you can define rules on the event bus to filter events based on their content, transform them if needed, and route specific events only to the specific targets like Lambda functions, SQSQ, step functions, state machines, etc. that need to react to them.
Ah, much more intelligent routing?
Exactly. It enables very loose coupling and accelerates modernization by allowing teams to build services that react to events without needing explicit dependencies or direct integrations between systems. While both EventBridge and SNS can implement publish-subscribe patterns, EventBridge is particularly ideal for these more complex, integrated, event-driven architectures involving many different event sources and targets, especially when integrating with SaaS applications or needing advanced filtering and routing logic.
Okay, let's switch to data. Analyzing large data sets is absolutely crucial for modern businesses trying to make informed, data-driven decisions. What are some key AWS services for tackling big data analytics, especially if you're looking for those serverless options that can simplify operations and reduce the management overhead often associated with big data platforms?
Yeah, the data analytics space on AWS is huge and constantly evolving, with serverless options becoming increasingly prominent. Let's look at three key services. First, AWS Athena. This is a really cool one. It's a serverless interactive query service that enables you to analyze data directly in Amazon S3 using standard SQL.
Query data right in S3 without loading it anywhere.
Exactly. That's the magic of Athena. You don't need to set up complex extract, transform, load ETL processes to move your data into a database first. You simply define the schema for your data files, which could be CSV, JSON Parquet, ORC, etc., residing in your S3 data lake. And then you can run standard SQL queries against that data directly using the Athena console or via JDBC ODBC drivers. It's fully serverless, meaning there's no infrastructure to manage, and you pay only for the amount of data scanned by your queries. This makes it incredibly cost-effective and easy to use for ad hoc data exploration, quick analysis, and even some BI reporting directly on top of S3. Second, there's Amazon EMR, which stands for Elastic MapReduce. EMR is a managed big data platform service that helps you process and analyze vast amounts of data using popular open-source distributed processing frameworks like Apache Spark, Apache Hive, Apache HBase, Presto, and others.
So this is for heavier processing jobs.
Typically, yes. EMR has traditionally required you to provision and manage clusters of EC2 instances. However, AWS has recently introduced an EMR serverless deployment option. This makes it significantly easier for data analysts and engineers to run applications built with these powerful frameworks like Spark and Hive without needing to configure, optimize, scale, or manage the underlying servers or clusters. It automatically provisions and scales resources based on the job's needs, again lowering the operational barrier significantly for running complex, big data processing workloads. And third, we have Amazon Redshift. This is AWS's fully managed petabyte-scale data warehousing service. Redshift is designed for high-performance business intelligence, BI, querying, analytics, and reporting on large volumes of structured and semi-structured data. It uses a massively parallel processing MPP architecture to execute complex queries very quickly across large data sets.
The data warehouse solution?
Precisely. Like EMR, Redshift traditionally involved provisioning and managing clusters of nodes, but now it also offers a Redshift serverless option. This automatically provisions and scales the data warehouse capacity up or down based on workload demands, aiming to deliver consistently high performance, even for demanding and unpredictable analytical workloads, while again, significantly reducing the operational overhead of managing the warehouse infrastructure. This allows data teams to focus more on deriving insights from the data rather than managing servers.
Okay, let's talk about speed. For applications that require absolutely lightning-fast response times, we're talking sub-millisecond latency, particularly for frequently accessed data where even a small delay can impact the user experience. What's the secret weapon? How do you achieve that kind of speed without constantly hammering a potentially slower back-end database?
The secret, very often, is caching, specifically using an in-memory cache. And the AWS service for that is Amazon Elasticache. Elasticache is a web service that makes it really easy to deploy, operate, and scale an in-memory data store or cache in the cloud. It supports two popular open-source in-memory caching engines, Redis and Memcache.
Redis and Memcache. Okay, so what's its purpose?
Its core purpose is to provide ultra-fast, sub-millisecond latency, and inexpensive access to copies of frequently accessed data. By retrieving information from a fast-managed in-memory cache like Elasticache, you dramatically improve your application's performance and responsiveness. You avoid the much slower process of repeatedly querying your primary disk-based databases, like RDS or DynamoDB, for common or computationally expensive query results.
So you query the cache first.
Exactly. Imagine a popular e-commerce website where product details or user session information are accessed millions of times per hour. Instead of hitting the main product database every single time, the application would first check the Elasticache cache.
Yeah.
If the data is there, a cache hit, it's returned almost instantly sub-millisecond. If it's not there, a cache miss, the application queries the database, gets the result, stores it in the cache for next time, and then returns it to the user.
So it reduces load on the database too.
Massively. You pay the price of the database query only once on the first request, and then you can quickly retrieve that same data potentially thousands or millions of times directly from the much faster in-memory cache. This significantly reduces the load on your backend databases, lowers latency for end users, improves overall application throughput, and enhances the user experience, especially for read-heavy or data-intensive applications.
Okay, one last scenario in this section. What if you have truly huge amounts of data? We're talking terabytes, maybe even petabytes, that you need to transfer into AWS, perhaps from your on-premises data center during a migration. But your internet connection is painfully slow or maybe unreliable, or the transfer would just take weeks or months over the wire. Shipping data physically on hard drives sounds kind of old school, but is there a modern, secure AWS service for that?
That's a very common challenge, actually, especially for large-scale data migrations, data center decommissioning, or even in edge computing scenarios where network connectivity is limited. And yes, AWS provides the Snow family of services, which are essentially physical devices designed for secure offline data transfer and edge computing.
Snow family, okay.
There are a few members. One, AWS Snow Cone. This is the smallest member. It's a small, portable, rugged edge compute and data transfer device. Think really compact. It weighs under 5 pounds. It comes with 2 vCPUs, 4 GB of memory, and either 8 TB or 14 TB of usable storage, HDD or SSD options. Snowcone is ideal for collecting, processing data locally using built-in compute, and then transferring that data from harsh or disconnected environments. You can transfer the data to AWS either offline by shipping the device back to AWS or online using the built-in AWS data sync agent once you have a network connection. Think of it for remote industrial sites, mobile deployments, or IoT data aggregation points.
Okay, small and portable. What's bigger?
2. AWS Snowball. This is the original workhorse, designed as a petabyte-scale data transport solution that uses secure, ruggedized appliances to transfer massive amounts of data into and out of the AWS cloud much faster than over the internet. Snowball directly addresses those critical issues like high network costs, long transfer times, and security concerns associated with large migrations over potentially slow or expensive network links.
So how does it work? They ship you a box.
Essentially, yes. You request a Snowball device through the AWS console. AWS ships you a rugged, tamper-resistant appliance. They look like reinforced suitcases. You connect it to your local network, use a client tool to load it up with your data. They come in various capacities, typically up to 80 TB or 100 TB of usable space per device. The data is automatically encrypted on the device. Then you ship the full device back to AWS using a prepaid shipping label. AWS receives it, decrypts your data using keys only you control via KMS, and uploads it directly into your designated S3 bucket. And within the Snowball line, there are also specialized versions called Snowball Edge.
Snowball Edge.
Yes. There's Snowball Edge Compute Optimized, which offers significantly more computing capabilities, more vCPUs, memory, optional GPU, allowing you to run more demanding applications or machine learning inference workloads directly on the device at the edge, even while disconnected. And there's Snowball Edge Storage Optimized, which focuses on maximizing storage capacity, up to 210 TB usable per device with object storage for those really large-scale data migrations or local data lake needs. Crucially, all Snowball Edge devices provide the ability to access the compute power of the AWS cloud locally by running EC2 instances or Lambda functions directly on the device, even in rugged, austere, or completely disconnected environments. This extends AWS capabilities right to the little edge of your network for local data processing, analysis, or filtering before potentially shipping terabytes of processed data back, rather than raw data.
Okay, we've covered a lot of specific services. But beyond those individual tools, there are some really foundational concepts and operational models that underpin almost everything we do in AWS. To truly understand the cloud, and especially to nail those conceptual questions on the cloud practitioner exam, we need to make sure we're crystal clear on these overarching principles.
Yeah, absolutely. Zooming out for a moment, understanding these core principles really helps you think more like a cloud architect or engineer, not just a user clicking buttons in the console. They provide the essential conceptual framework for making informed decisions about which services to use, how to design resilient and secure systems, and frankly, how to avoid making critical, costly mistakes when operating in the cloud environment. Tag the AWS shared responsibility model.
Okay, let's start with a really big one. The AWS shared responsibility model. This comes up all the time. It's critical not just for the exam, but for understanding cloud security in general. You often hear it quoted as security of the cloud versus security in the cloud. What does shared responsibility truly mean in practice when using AWS? How does it actually delineate the roles between AWS and me, the customer?
Yeah, the AWS shared responsibility model is absolutely fundamental, and you must understand it. It clearly defines that security and compliance is a shared undertaking. The core principle is exactly as you said. AWS is responsible for the security of the cloud, protecting the underlying infrastructure that runs all the AWS services. And you, the customer, are responsible for security in the cloud, securing your data, applications, and configurations that you run on that infrastructure. Importantly, the specific division of responsibilities varies depending on the services used. For example, your responsibilities are much greater when using an IaaS service like EC2 compared to a fully managed PaaS service like RDS or a SaaS-like service. We can generally categorize the controls into 3 types to make it clearer. 1. Inherited controls. These are controls where AWS is solely responsible because they manage that aspect of the global infrastructure. A prime example is physical and environmental controls, securing the actual data centers, guards, gates, fences, power, cooling, the network infrastructure connecting them, and the foundational compute, storage, block, and database services. You, as a customer, inherit these protections automatically. You don't worry about guarding the AWS server racks.
Right, AWS handles the physical stuff.
Exactly. 2. Shared controls. These are controls that apply to both AWS and the customer, but operate at different layers or contexts. For example, patch management. AWS is responsible for patching the underlying hypervisors and infrastructure hosts that run their services, but you are responsible for patching your guest operating system, like Windows or Linux running on your EC2 instance, and any applications you install on it.
Okay, so we both have patching duties.
Yes. Similarly, for configuration management, AWS maintains the configuration of its underlying infrastructure, but you are responsible for configuring your guest OS, your databases, your applications, your firewalls, security groups, NACLs, and even something like awareness and training. AWS trains its own employees on security best practices, but you are responsible for training your own employees on how to use AWS services securely. 3. Customer responsibilities. Security in the cloud. This is entirely your domain, regardless of the service. It includes things like managing your data, including deciding on and implementing encryption options client-side or server-side, classifying your assets based on sensitivity, managing access using IAM tools, users, groups, roles, policies, MFA, configuring network controls like security groups and network ACLs correctly, and managing client-side data encryption if you choose to use it. Let's use a concrete example, like Amazon RDS, which is a platform as a service. With AWS managed services like RDS, Lambda, or S3, AWS is responsible for most of the configuration and management tasks related to the infrastructure.
For Amazon RDS specifically, AWS manages the underlying infrastructure provisioning, the operating system patching, the database engine setup and patching, automated backups, high availability setup, etc. That's a lot they handle.
Yeah, that sounds like a lot less work for me.
It is. However, even with these managed services, customers are still responsible for managing their data, including choosing encryption options like KMS, classifying their assets, and using IAM tools to apply the appropriate permissions for accessing the database management APIs. You, the customer, are also responsible for managing specific database engine settings and parameters, designing and building the actual relational schema, tables, indexes, and crucially, configuring network traffic protection using security groups to control who can connect to your database instance. This clearly reinforces that even with RDS, customers do not have complete control over the underlying host OS or hardware. That's part of the shared responsibility that AWS manages for you. That's a key distinction from running your own database on an EC2 instance, IaaS, where you do control almost everything from the OS up.
Okay, that model is really key to grasp.
Absolutely. It's a fundamental mindset shift required for operating securely and effectively in the cloud. It's all about understanding where your focus needs to be depending on the services you choose. Tag elasticity.
Okay, another fundamental concept. We hear elasticity mentioned constantly in the cloud context as a major advantage, almost like a superpower compared to traditional IT. What does that truly mean for our resources in practical terms? How does it help us manage fluctuating demand and potentially optimize costs?
Yeah, elasticity is arguably one of the most defining, truly transformative characteristics and benefits of cloud computing. It refers quite simply to the ability of a service or application to automatically scale its resources out or in horizontally, or sometimes up or down vertically based on changes in demand, often in near real time.
Like a rubber band.
Exactly like a rubber band is a great analogy for your computing power or capacity. When demand for your application suddenly surges, maybe due to a viral marketing campaign, a Black Friday sale, or a major trending news event hitting your website, your cloud infrastructure automatically stretches to meet that increased load, perhaps by adding more servers, increasing storage throughput, or handling more network requests. Then, just as importantly, when demand drops back down maybe overnight, or after the event ends, it automatically snaps back, removing those extra resources so you're not paying for them when they're not needed.
So it prevents waste and handles peaks.
Precisely. Elasticity prevents both costly over-provisioning, paying for idle resources just sitting there waiting for peak load, and detrimental under-provisioning, where your application slows down or crashes during peak load because it doesn't have enough resources. A classic foundational example of this in AWS is Amazon EC2 auto-scaling. This service can automatically monitor metrics like CPU utilization or request count on your EC2 instances, and then automatically add or remove instances from your fleet based on rules you define, ensuring you always have the optimal number of instances running to meet current demand while minimizing costs. It's all about meeting demand precisely and dynamically without manual intervention. Hashtag infrastructure as a service. We touched on this earlier with EC2, but let's formally define it. Where does a fundamental service like EC2 fit into those broader categories of cloud service models, IaaS, PaaS, SaaS? And what does that IaaS category imply specifically for customer responsibility and the level of control they have?
Right. Services like Amazon EC2 virtual servers, Amazon VPC networking, and Amazon EBSS3 storage are categorized as infrastructure as a service, IDaaS. IaaS essentially provides the basic building blocks for cloud IT. It gives you access to fundamental computing resources like networking features, virtual machines, compute capacity, and raw data storage space, typically over the internet on a pay-as-you-go basis. This service model offers the highest level of flexibility and management control over your IT resources compared to PaaS or SaaS. In many ways, it's the most similar model to traditional on-premises IT infrastructure management, just running on someone else's hardware in their data center, but with the added cloud benefits like elasticity and pay-as-you-go pricing.
So I control more, but I also have to manage more.
Exactly. As a customer utilizing IaaS, you're responsible for managing almost everything above the hypervisor level. This includes the guest operating system, installing it, patching it, securing it, any application software or utilities you install in that OS, managing middleware, runtime environments, your data, and critically, the configuration of the network firewall provided by AWS, which is usually the security group associated with each instance. You essentially manage the operating system and everything above it, while AWS manages the underlying physical hardware, the virtualization layer, the hypervisor, and the core network infrastructure connecting everything. You have the most control, but also the most responsibility. Hashtag Amazon Machine Image, AMI.
Okay, last fundamental concept here. When you launch an EC2 instance, you don't start from a completely blank slate. You need some kind of pre-configured template that defines its initial software state, right? What is that template called in AWS terminology, and what exactly does it contain that makes it so useful for launching instances quickly and consistently?
That template is called an Amazon Machine Image, AMI. You absolutely need to know this term. An AMI is essentially a template that contains a software configuration needed to launch an EC2 instance. It's like a blueprint or a master image for your virtual server. This configuration typically includes the operating system, like a specific version of Linux or Windows Server, potentially an application server like Apache, NGINX, or Tomcat, and possibly any specific applications, libraries, or configurations you need pre-installed right from the moment the instance boots up.
So it bundles everything needed to start.
Pretty much everything. For the base software environment, yes. The benefit of AMIs is immense, especially for consistency and speed. They save a lot of time during instance launch because you don't have to manually install the OS and baseline software every time. They also help avoid configuration errors by providing a pre-configured, standardized, and potentially pre-hardened setup. You specify an AMI when you launch an instance. You can use AMIs provided by AWS, buy them from the AWS marketplace, often with commercial software pre-installed, or very commonly create your own custom AMIs from instances you've already configured.
So I can make my own template.
Absolutely. And then you could launch as many identical instances as you need from that same custom AMI, ensuring consistency across your fleet, enabling rapid deployment, and simplifying the scaling of your applications significantly. It's like having a perfect clone button for your server's entire software environment. Hashtag tag tag outro.
Wow. Okay. What an incredible, pretty deep journey through the really essential services and concepts for anyone tackling the AWS Certified Cloud Practitioner exam. We've explored, well, pretty much everything from those foundational pillars like virtual servers, EC2, and the diverse storage options, EBS, EFS, S3, through to smart strategies for cost management using tools like Cost Explorer and savings plans, then into robust security measures with IAM, security groups, KMS, and understanding that shared responsibility model. We covered streamlined operations using Trusted Advisor, AWS Health, and the well-architected framework principles. And we even touched on more modern decoupled architectures using services like SQS, SNS, EventBridge, and the power of serverless compute with Fargate and data analytics with Athena and Redshift serverless. Our aim really was to give you the most important insights, those nuggets of knowledge, so you don't just feel ready to maybe pass your exam, but feel truly well-informed and confident in your fundamental understanding of the AWS cloud's breadth and, maybe more importantly, its depth.
Indeed. And stepping back for just a moment, connecting this all to the bigger picture. The goal, as we said at the start, isn't just about passing an exam, though that's a great achievement. It's really about building a strong conceptual foundation for understanding and, more importantly, effectively leveraging the cloud in real-world scenarios to solve actual business problems. These core principles, we discuss things like the durability guarantees of S3, the elasticity offered by autoscaling, the critical nuances of the shared responsibility model. These are not just definitions you need to memorize for a test. They represent fundamental mindsets, design patterns, and operational approaches required for successful, sustainable cloud adoption and for designing systems that are secure, resilient, cost-effective, and truly capable of delivering business value.
So true. So, what does this all mean for you, the listener, as you continue your preparation? As you go back and review these topics, maybe listen again. Don't just try to memorize the names and their basic functions. Really push yourself to think about the why behind each service. How does it actually address a specific business or technical challenge? Why is S3 designed for such incredible durability? What specific problem does that solve for you or for a business? Why is using Route 53 with latency-based routing so important if you have a global audience? And what's the actual tangible impact on the end user experience? Why are tags so utterly indispensable for effective billing and cost management, especially in a complex multi-account environment? Understanding these underlying motivations, the problems they solve, will solidify your knowledge far, far beyond just rote memorization. It makes the knowledge stick and makes it applicable. So as you go forward from here, maybe a final thought to ponder. What's one AWS concept or service we discussed today that you feel you could explore just a little bit further? One where you want to truly master the why behind its power. And how might gaining that deeper level of understanding transform your approach, not just to the exam, but to designing and thinking about cloud solutions in the future?